equals the fourth root of 5 plus the fourth root of x. Good. Perfect. Good. Uppercase f of x. This is a constant. I have to copy it. Which function prime is 1?
X.
That's it. Plus, this has to be changed into x to 1/4. So, increase by 1, the power by 1, x equals 1/4 plus 1 is 5/4 over 5/4 plus a constant c. I have to flip the denominator. So uppercase f of x will be whatever this number is, who cares? Nobody cares. 4/5 x to 5/4 plus a constant c. And this is the most general antiderivative of the given function, this one. Can we move on now to those with the initial condition? By the way, which function prime is -3? Remember, when you see this, you have to have in your mind's eyes, -3 times 1 over the square root of 1 minus v squared. Which function prime is this? -3 and 1 over the square root of 1 minus v squared. Which function prime will give us this -3? I'm going to keep the 3 outside. Who cares? -1 over the square root of 1 minus v squared.
We just did that.
Nope, not with the square root. There is.
I think it was in something we were differentiating. We didn't just do this, but we did a problem where we had to talk about that. I feel like last class or the previous class.
Yes, it's a very important function. Which function we differentiate to get -1 over the square root of 1 minus v squared? There is only one function.
Wouldn't it just be the square root?
Arc cosine x.
Oh, that's not what I was saying.
Arc cosine x prime is -1 over the square root of 1 minus v squared. Oh, of course, v, not x. Arc cosine v prime is -1 over the square root of 1 minus v squared. Okay, anything else, or can we move on to the ones with initial condition?
We can move on.
Okay, so let's take a look, let's say at 27, and then we have a different type of situation. They're all the same, but more work, and you'll see in a moment what I mean by more work. Okay, so I am on page 6. Let's look at page 6. Not page 6, I'm sorry, I'm talking to myself. Okay, so 27. So we have f of x equals 2e to the x minus 6x, and they are telling us that f of 0 is 1. What does that mean? Yes, this is the initial value. But why is it given to us? Well, because we are no longer asked to determine the most general antiderivative. They are basically giving us an initial value. They're really telling us find the function, the unique function that has such and such. Good. So can anyone give us f of x so far? Without the initial value, of course, so we have to determine the most general antiderivative and then plug it in. So 2 is 2. Which function? Yes. Which function prime is?
e to the power of x.
Good. I copy 6, negative 6. Which function prime is x?
X squared over 2.
Exactly. Plus a constant c. So yes, I will simplify and I get 3. So then f of x equals 2e to the x minus 3x squared plus a constant c. But they're telling us that f of 0 is 1, which means 1 equals 2e to 0 minus 0 plus c. How much is e to 0? I know everyone knows e to 0.
1.
Exactly. Oops. So then I have 1 equals 2 plus c. I move 2 to the other side. 1 minus 2 equals c, so c equals negative 1. I have to plug it in. So then uppercase f of x equals 2e to the x minus 3x squared minus 1. And this is not the most general antiderivative, but unique function that has the same derivative given to us, but also fulfills this condition that f of 0 is 1. Okay, now we're moving on to next set. The question is the same. Find f. But this time we're given the second derivative, the third derivative, whatever, all sorts. The mechanism is identical. Some of them, as you see, do not have an initial value. So we are looking for the most general antiderivative or function f. But these have initial value. So they want us to find a specific, unique function. Oops. So let's start. Of course, we cannot find the function directly from the second derivative to f or from the third derivative to f. We have to go step by step. So let's choose. We choose or I choose?
Can we do, what was the first one, just to start, the 24x, number 29?
Okay, so we start with 29. So we have f of x equals 24x. The second derivative of f of x equals 24x. Perfect. Okay, very good. So we're asked to find f, and that's the correct notation, because when we are given the second derivative, we will go backwards to the first derivative and then further to f of x. So let's find f prime. 24 is 24. Which function prime is x?
X over 2 to the power of 2.
Very good. Plus a constant c1. I simplify and I get 12x squared plus a constant c1. I'm moving on to f of x. I copy 12. What function prime?
I'm sorry. Why is it C1?
In a moment you'll see. 1 second.
Sorry.
I promise. No, very good. Perfect question. But you're gonna.
Is that like a second derivative constant?
Correct.
Because it has to go twice or not?
So, which function prime is x squared?
X over 3 to the power of 3.
X to the third divided by 3. Plus, which function prime is c1?
E times x.
c1x plus c2. And yes, I have to simplify first. So f of x equals 4x to the third plus c1x plus c2. This is the function, family of functions, whose second derivative is that. Now, I'm sure the question was answered. Why c1 and c2? You can say, I don't like c1 and c2. Okay, fine. Then use c and d. C, and D, if you don't want C1 and C2. Anything, but they may or may not be equal, so I have to use different notation. Good. Anything else? Anything else you'd like to choose? So we can practice going backwards from the second or the third derivative. Anyone?
We could try maybe the third derivative one.
Okay.
33.
Yes, which one?
Why not? 35.
35, very good. I am on page 7. And we're looking at 35. In 35, we have f, third derivative of f of t equals 12 plus sine t. Awesome. Good. So the same question, they want us to find f of t. Good. I cannot. From the third derivative, I have to go back step by step to the second one. Which function prime is 12? Which function prime?
12x.
12t. Very good. Plus or minus, we'll see. Which function prime is sine t?
Cosine.
But negative.
Negative cosine.
Good. Plus, if you don't want C1, C2, I will say C. So then the second derivative equals 12t minus cosine t plus C. Now you go back to the first derivative. 12. Which function prime is t?
T over 2 squared or t squared over 2.
Good. Minus. Which function prime is cosine?
Negative sine or just
Yes, just sine, yes. Plus. Which function prime is c?
dx.
Ct plus a constant d. I prefer it's easier C1, C2, C3, but that's another option. So f prime of t equals 6t squared minus sine t plus ct plus d. Finally, f of t, 6. Which function prime is t squared?
That'd be like t to the power 3 over 2.
Yes. Minus, or which function prime is negative sine t?
That should be plus cosine.
Yes. Plus c. Which function prime is t?
T over 2 or t squared over 2.
Plus which function prime is d?
dt.
Yes. dt. Plus which function prime is 0? A constant e. See, it looks okay, but it's a little bit more weird with c, d, and e. Better c1, c2, c3. But it's the same thing. It doesn't matter. Whatever you prefer. Any questions? Okay. I would like to choose 39. And then you choose. 39. F prime of t equals 4 over 1 plus t squared. F of 1 is 0. Okay. When you look at this, I want you to see this, because that's what it is. Once you see this, you can never undo that. You will always see it correctly, because this is more difficult to work with than this. So now I have f of t. 4 is outside. I have to remember which function prime, a very important function, is this.
That looks like one of the arc ones. Okay.
Yes, plus a constant c. That's it. Now I am given this information that f of 1 is 0, meaning when t is 1, the function is 0. The function is 0 with 4 arc tangent 1 plus c. So now I have to remember which angle has tangent 1. And I will replace it here.
5/4.
Pi over 4. So 0 equals 4 times pi over 4, which is pi, plus c. So 0 equals pi plus c. C equals negative pi. I have to plug it back in. So this one here was the most general antiderivative. But this one, we are given an initial value, or initial condition if you want. So then we're asked to determine the unique function whose derivative is this, but also passes through the point 1, 0. So then the final answer for this will be here. 8. So f of t equals 4 arctangent t minus pi. Unique. There is no something called parameter. They are constants. They are constants, but also called parameters. Any questions on this? How do we feel about it so far?
Definitely need another couple examples.
Sure. Anything. They're right here in front of us. You choose.